find a unit normal vector to the surface x square y plus 2xz square minus 8 equal to 0 at 1, 0, 2. This is what is asked. Okay. So ultimately what we have to find, this is a very important. See, if you are asked to find a normal vector, see, del phi is normal to phi at given point, at that point. But we are not asked to find a normal vector, we are asked to find a unit normal vector. So how will you make the vector as a unit normal vector? Nothing. Del phi divided by mod of del phi. That's what we have to do. Clear? So find del phi divided by mod of del phi at that point. That's what is the answer. So what is del phi? Del phi is nothing but, for the given vector, it is nothing but dou by dou x times x square y plus 2xz square minus 8 plus j vector times dou by dou y of x square y plus 2xz square minus 8 plus k dou by dou z of x square y plus 2xz square minus 8. So when you simplify this, what we will get? We will get this as I vector times 2xy plus 2z square plus j vector times, here x and z are constant, so we will be getting it as x square plus x square, that's it, plus 0 you will be getting because there is no y term here, plus k vector times dou by dou z of x square y will give you 0 because there are no z terms, and 2xz square will give me 4xz. That's it. This is the value of del phi. Now at 1, 0, 2, del phi will be what? We have to substitute these values. So this will be, when we substitute the values, it will be what? 8i, this is the value of x, y and z. So it will give me 8i, because this term will become 0. This is 2 into 2 into 2, 8i plus j plus 4xz will give me 4 into 1 into 2, that is 8k vector. So this is the value of del phi. This is the value of del phi. Now how will you find the unit normal vector? Unit normal vector is nothing but, whenever you are asked to find the unit vector, it is nothing but, see, if you have a vector called a vector, you have to find the unit vector along a vector is nothing but a vector divided by modulus of a. Similarly, here we have to find del phi divided by modulus of del phi, that is nothing but 8i plus j plus 8k divided by root of 8 square plus 1 square plus 8 square, that is nothing but 8i plus j plus 8k divided by root 129. This is the answer. Okay. Now let us solve one more problem. This is another interesting one. Let me take a new page for this. So this is the question. The question is, find the angle between the surfaces x square plus y square minus z minus 3 equal to 0 and x square plus y square plus z square minus 9 equal to 0 at 2, minus 1, 2. See, this is a very interesting problem. So here you have to understand one thing. You have a surface here, okay, and you have another surface. This is surface S1, this is surface S2. At some point you are asked to find what is the angle between these two surfaces. Remember that the angle between these two surfaces is nothing but angle between to surface is nothing but angle between normal to that surface. Okay, to illustrate, let us see it in terms of simple planes. Say this is one plane, okay, and this is another plane. The normal will be here in this direction. Here the normal will be here. Clearly it is visible that these two planes are 90 degree. The angle between them is also 90 degree. See that. This angle is same as this angle. Correct? These two angles will always be same. So angle between two surfaces is nothing but angle between normal to that surface. Please remember that. This is very, very important point. Now, so that is, there is one normal here. Rather it is something like we are evaluating at that point, right? So the normal to this surface here will be in this direction. The normal to S2 will be in this direction. This angle is same as this angle now. Correct? Yes or no? So angle between surfaces, say this is the normal to NS2, NS1. The angle between the normal to the surfaces is nothing but the angle between the surfaces itself. Now how to find normal? How to find normal? Del phi. Correct? Del phi will give me. So let me take this as phi 1 and let me take this as phi 2. Okay, where S1 is nothing but phi 1, S2 is nothing but phi 2. Correct? Now I have found the angle between. Now I have found del phi 1, del phi 2. How will I find the angle between that? I know. Say for example, if I have two vectors called A vector, B vector, if I take the dot product of them, what it will give me? AB cos theta. So from this, how can I find cos theta? A vector dot B vector divided by mod of A into mod of B. So theta is nothing but cos inverse of A vector dot B vector divided by mod A into mod B. Correct? So where theta is the angle between the surface. Correct? Theta is nothing but angle between A and B. So now what we are going to do? Del phi 1 is gradient of phi 1, that is normal to phi 1. Del phi 2 is gradient phi 2, that is normal to phi 2. Now angle between normal is nothing but angle between surfaces. So we are ultimately it is the finding the angle between del phi 1 and del phi 2. So angle between del phi 1, let this be theta. Let theta be angle between phi 1 and phi 2. Implies theta will be angle between normals also. So del phi 1 and angle between del phi 1 and del phi 2 also, because angle between the surfaces is nothing but the angle between the normal to the surfaces. We have seen it, right? So ultimately theta is nothing but cos inverse of del phi 1 dot del phi 2 divided by del phi 1 del phi 2. That's it. This is the answer. Ultimately we have to find these things and plug in these values here. We will get the answer in. Correct? So we know what is phi 1, we know what is phi 2. From that we can find, if I know this and this, I can find this and this at that given point. Correct? 2 comma minus 1 comma 2, which is the given point. Correct? So what is del phi 1? Del phi 1 is nothing but what? I have to find I vector times dou by dou x of x square plus y square minus z minus 3 plus j vector times dou by dou y of x square plus y square minus z minus 3 plus k vector times dou by dou z of x square plus y square minus z minus 3. So del phi 1 will be what? I vector times 2x plus j vector times 2y plus k vector times minus 1. Correct? So at 2 comma minus 1 comma 2, del phi 1 is nothing but what? What is del phi 1? It will be nothing but 4i minus 2j minus 2j minus k, right? It will be minus k, because k is not having any term, it is just minus 1k, it's independent of x, y, z. 4i minus 2j minus k vector. This is what we will get. Clear? Okay. Now we have to find del phi 2. What is del phi 2? It is nothing but I vector dou by dou x of x square plus y square minus x square plus y square plus z square minus 9 plus j vector dou by dou y of x square plus y square plus z square minus 9 plus k vector dou by dou z of x square plus y square plus z square minus 9. So if I simplify this, what will I get? It is nothing but I vector times, I will get dou by this 2x plus j vector times 2y plus k vector times 2z. This is what I will get as del phi 2. So at 2 comma minus 1 comma 2, del phi 2 is nothing but plus 4i minus 2j plus, here it is dependent on z, so plus 4k. Correct? This is what we will get. So now find theta. Find theta. What is theta? Theta is nothing but cos inverse of del phi 1 dot del phi 2 divided by modulus of del phi 1 modulus of del phi 2. So this is nothing but cos inverse of del phi 1 is what? We calculated it, right? Del phi 1 is nothing but 4i minus 2j minus k vector dot phi 2 is 4i minus 2j plus 4k divided by determinant of modulus of this, 4 square plus minus 2 square plus minus 1 square into root of 4 square plus minus 2 square plus 4 square. This is what it is. So on simplification it will give me cos inverse of 4 into 4 16 plus 4 minus 4 divided by root of 16 plus 4 root 21 into root 36. There is nothing but cos inverse of 16 by root 36 is nothing but 6 root 21. This can be simplified as 8/3. So theta is nothing but cos inverse of 8/3 root 21. This is the answer. Clear? Now please be careful between the radian and the degrees mode when you are using these type of things. Okay, that is very important. Please observe whether the answer is given in radians or degrees. Accordingly you have to report the answer. Clear? Fine. Okay. This one is another interesting problem now. We are going to solve one more problem. Here del phi is given to you. You are asked to find phi. Del phi is equal to yz I vector plus xz j vector plus xy k vector. Find phi. This is what is asked. This is another interesting problem. So by definition, what is del phi? Del phi is nothing but I times dou phi by dou x plus j times dou phi by dou y plus k times dou phi by dou z. Okay, so this value is what is sitting here, this value is what is sitting here, and this value is what is sitting here. Clear? So the moment del phi is given, we know that dou phi by dou x is nothing but yz. Dou phi by dou y is nothing but xz. Dou phi by dou z is nothing but xy. Now I have to integrate this. Correct. See, dou phi by dou x is yz. So dou phi is nothing but yz dot dou x. So if I integrate this, I will get phi. Now one thing you have to understand here. This is dou x, it's not dx. This is not dx, it is dou x. That means what? Now this problem is simple in one angle, but it is equally complicated in some other direction. We have to pay careful attention here. Let me take a new page for that. Okay, let me little bit digress from the problem and give you one small illustration. Okay, let me take some other scalar called lambda. Let lambda, this is just an illustration. Okay, let lambda equal to xy plus y. Let me take this as lambda 1. Let me take some other thing called lambda 2, which is xy plus 3. Okay. Now, what is dou lambda 1 by dou x? It is x. I'm sorry. It is y. It is y, not x. That is xy. X is y is a constant. X on differentiation will give me y. This y on differentiation will give me partially with respect to x will give me 0. Dou lambda 2 by dou x is what? This will also give me y plus 0. So this is also y. This is also y. Now, if I have to find what is lambda by looking at this, if I have to find what is lambda by looking into this, how will you find? Dou lambda 1 is nothing but y dou x. So lambda 1 is nothing but integral of dou lambda 1. This is nothing but y integral of y dou x. There is nothing but xy plus something. Okay. Now let us do the same thing here. Lambda 2 is nothing but integral of dou lambda 2. That is nothing but integral of y dou x. This is also nothing but xy plus c. Now pay attention, look at lambda here. Lambda is y. Since I partially differentiated lambda, I don't know whether this constant is really a constant like 3 or a term which is not containing x like y. So we don't know. See, this constant and this constant are not same. This constant is a number, that is 3, whereas this constant is a function not containing x term. Because this constant is not 3, it's not a number, it is a term called y, which is another component of this function, but it is not containing x term. So when we are doing partial integrations, we have to be very careful. We don't know whether the number is the constant is really a number, or a constant is a function which is not containing the corresponding term. We have to be really very careful on this point. So whenever we do partial integration, we always assume the constant to be a function not containing the corresponding variable. Is this clear? This is a very important concept you have to remember. Later we will substitute we will evaluate the constant. Later evaluate the constant. Clear? So now let us go back to the problem. We had dou phi by dou x to be, now we are coming back to the problem. We found that dou phi by dou x is nothing but yz, dou phi by dou y is nothing but xz, dou phi by dou z is nothing but xy. Now when we integrate this, phi is nothing but integral of dou phi, that is nothing but integral of yz dou x, this is nothing but xyz plus, what is this? Now this is going to be a constant. What is this constant now? This constant can be a function not containing x, correct? Function not containing x means it can be a function of y comma z, purely a y and z term. We don't know, correct? Now go to display dou phi by dou y. What we will get? Phi is nothing but integral of dou phi, it is nothing but integral of xz dou y. What we will get here? This is again when we do partial integration, we will get xyz plus, here it can be a function not containing y. That means it can be a function of x and z. We don't know. It might be a constant also, it might be a function containing xz also. We don't know. It is better to assume this as a function and later prove that this function is a constant. Now from this, what is phi? Phi is nothing but integral of dou phi. It is nothing but integral of xy dou z. What is this? This is nothing but xyz plus function of x comma y. We don't know. This might be a constant or it can be a function of x and y. We have to evaluate it. So if I see, but all these three phi's are same. But all these three phi's are same. Correct? Yes or no? All these three phi's are same. Because we have evaluated the same thing here, correct? That means what we are going to do is, what is phi? Phi is going to be xyz plus a function. Let me write this clearly here. Phi is nothing but xyz plus function of yz. It can be a function not containing this, but a function not involving x, function not involving y, function not involving z. Function of xy means what? Function not containing z. Here this is nothing but function not containing y. This is nothing but function not containing x. That means this part is nothing but a function not containing x, not containing y, not containing z. Therefore this part has to be a constant. Here we conclude it. This is how it has to be done. And therefore phi is nothing but xyz plus constant is a solution. How we are concluding it's a constant? From this, that is from 1 we can say that this part is a constant. The part which is remaining is a constant which is not containing x. From the other part we see that it's a, see, if I equate this phi and this phi are the same phi's, correct? That means xyz plus a function not containing x should be equal to xyz plus function not containing y should be equal to xyz plus function not containing z. All the three are same. That means if I try to evaluate the coefficient of x, it should be there. If there is some x term here, there has to be some other x term here also. But here there are no x terms. But here you are saying that there can be x term, there can be x term. Here there is no y term. Here there is no y term. You are saying that here and here there can be y terms. Here there is no z. Here and here. But all the three are same. That means that has to be a constant. You cannot say that you don't have a z term here and you have a z term in 2, you don't have a z term in 3, but you have in 1 and 2. That means 1 and 2 cannot be equal to 3. Correct? So if 1 equal to 2 equal to 3, the only way is the remaining part has to be a constant. Because all the three are evaluated for the same phi. Clear? This is very important. Please remember this. Okay. Thank you.